To demonstrate this, I'm going to write a simple boot sector program in assembly using the NASM Assembler. So I'm going to start by opening a new assembly file and call it boot.asm. And the first directive I'm going to use is called org. And this will tell NASM where this program starts executing. Now, since I know that the BIOS loads us in a specific address in memory, we can just tell NASM that we start at 7C00. Now I can start writing the code of the program. So I'm going to start the label here, start. And first thing I'm going to do is switch the video mode from text to graphics. So I have here documentation of the IBM Personal System 2 or PS2. And a lot of new things to the personal computer world came from this, including VGA. And this came out in 1987. I'm going to jump to the section that talks about interrupt 10. And you can see that this interrupt is related to video, and this is 10 in hex. Now in this video I'm going to use hex numbers in 0x because this is also supported by NASM. But note that you can also use the H in the end of the number as notation as well. So we already know that the interrupt is going to be the video interrupt, so let's start by writing this instruction over here. But before executing the interrupt, I'm going to need to select the mode. So first of all, select the service, which is set mode. This is the set mode video service. And we do so by setting AH to 0. And then let's take a look at the documentation of the set mode video service. So you can see that set mode gets the requested video mode through the AL register. And here we can see the table with all the modes in hex. We're going to use mode 13. And this will give us, first of all points addressable, APA, which means graphics, as compared to alphanumeric, which is text. And this will give us 256 colors. Now after this interrupt executes, we can start using the frame buffer in this address in memory. This is where the buffer starts. Now in order to access this address, I'm going to need to select the data segment to be this over here, and then we can start accessing the buffer. So we're going to set the data segment to BX and move into BX A000. Now you can't move this directly into DS, so I'm using BX as a temporary register to transfer this. Okay, and now we can start writing into the video buffer itself. So let's write the color green, for example. So I'm going to start a label here, and let's set the counter to be 10,000. So we're going to write 10,000 pixels. Each pixel is represented by a byte, and the byte values are an index in the palette, which I'll show you in a second. First of all, I'm going to transfer the CX register into BX, because we can only use a specific subset of registers to address memory. Can't use CX to address memory directly. BX can be used though. Finally, I'm going to write into the memory address. So I'm going to use another move instruction. And this time I'm going to use BX as a pointer to memory. And this will be denoted by these square brackets. And I'm going to write the value in hex 30, which is going to be a green color. And then I'm going to use the loop instruction. Let's take an example of how you can locate this in the Intel official documentation. So go here to the side. And we know that loop is A until L. And here's loop. And you can see this instruction over here is what we're using. And the description, decrement count, which is ECX. And jump if the count is not 0. So I'm going to tell it to jump to green if CX is not 0 yet. And finally, afterwards, I'm just going to spin forever. So jump dollar is going to spin to the same address over and over again. Finally, to make this a valid boot sector, we're going to need to end this with a specific magic. So I'm going to use another NASM directive right now. And this is going to be times. And you can see that this causes the instruction to be assembled multiple times. You can see here an example of times being used to write 64 zeros in the binary. So this is basically equivalent to writing db0 64 times. And db, by the way, is defined byte. Now what I want to do is I want to fill the rest of the binary with zeros until we reach the very end of the boot sector in which I need to write a specific magic. So I'm going to use here times and then 510. Because the boot sector size is 512 bytes, but the magic is 2 bytes. So I'm going to just decrease the magic from here. So 510 minus dollar, so minus the current address, plus start. And this over here will effectively just decrease the size of the program. Because basically we're saying here minus the current address, the current line address over here, plus the address in memory of the start of the program. And finally, I'm going to just fill it with 0, so define byte 0. And now we can put the magic number. So define word. It's going to be 2 bytes. 0x AA55. If you don't put this number, the BIOS will think this is not bootable. Now let's save this. And I'm going to assemble this with NASM. And we have here an error. Let's fix it in line 14. We need to specify that this is on 1 byte in memory. Okay, after NASM assembled this successfully, you should have here a boot file, which if you take a look at the size, is exactly 512 bytes. So I'm going to start this with a PC emulator of QEMU. I'm going to pass this as the floppy drive. So FDA, the first floppy drive, is going to be boot. And you can see it works. We see here the color green. Let's add here another color. So I have here the Wikipedia article about mode 13. And you can see here the color palette. We used one of the green colors, which is about over here. Let's use a blue color. So a blue color would be like, if we used hex 30 for this, blue would be about hex 20. So let's do blue and then red, which is going to be like about 27 in hex. So I'm going to just copy this. Let's call this blue. And blue would be 20. Also, I'm going to skip over the first pixels. So that's going to be 10,000 plus. Oh, and let's fix this. And this will be red, which is about 27. This will be 20,000. Okay, let's try this. Okay, nice. Now let's test this with real hardware. So I'm going to write this into a real floppy disk and boot this on an old laptop I have. Okay, if I run here cat and then /proc/partitions, you can see over here SDC. SDC is my floppy disk. You can see it's 1,440 kilobytes or 1.4 megabytes. I'm going to write the boot image we just created to the floppy disk. I'm going to use DD for this. Input file is going to be the boot image. Output is going to be to the floppy disk. Dev SDC. Okay, and you can see the bytes are copied. Now we can test this with the computer. Make sure you run sync before you disconnect the floppy drive. Okay, now after copying the bootloader to the first sector of this floppy disk, I'm going to insert it into this floppy drive and boot this 1999 Sony Vaio laptop. And you can see it works. Thanks for watching.